Got it. Yeah, thank you for having me here. Originally, my title was the same thing, but I put of like social curiosity because I thought I would have something to say about it. And then I thought about it and I was like, I don't actually really know um, what actually is the computational basis of social curiosity. So I'm just going to mostly talk about work I've done, but I am going to try to connect it a little bit to social curiosity at the end. I didn't do any of the work I'm going to talk about. It was done by Paula Fernandez, who's a close colleague, and Amanda Royk and Marlene Berg, who are graduate students with me. And I just get to talk about it. So I want to start by showing you the kind of problem that I'm kind of interested in. So this is what it looks like when you walk around. This is Grand Central Station in New York City. And if you're here, there's kind of like a lot of things that you need to do to be able to navigate this space, right? Very quickly, you need to parse what you're seeing. You need to figure out like what things here are objects and what things here are agents, including humans, but maybe non-humans also like pets, right? And then you need to realize, okay, if you want to navigate the space, you have to realize that every time you take a step, everyone around you is also moving, and they're moving in different directions and at different speeds. So you need to be able to make some kind of constant predictions around you, right? And then as you're navigating the space, that's going to take you some of the way, but it's not always going to. Let me replay it. It's not going to take you all of the way, right? Sometimes like you start to realize that you might run into someone. And at that point, you very quickly start to negotiate and figure out like, is this person also aware that we're going to run into each other? Like who's going to take the corrective action? That's just the basic stuff you need to do to be able to like walk around this environment. On top of that, you're also doing all of these additional inferences. Like you might very quickly be noticing who here is doing is at work in the station, who is a tourist, who's kind of like coming out from work, who's distracted, who's tired. And on top of that, we can even do all of this kind of stuff in the background while you're walking with someone and having a conversation about like something that happened to you, right? So what I really want to understand is basically like what is going on in our minds that allow us to do like this kind of like really rich and complex social intelligence. So what are the representations? So like what is actually the way we capture the people's behaviors, and what are the processes that are going on? As you probably all know, but just to get us on the same page, a lot of people have been working on this. So it's kind of like, it's a good problem to work on because we have some good advances, right? So like the idea is that the way you reason about other people, it's what we like to call a theory of mind, right? So you kind of have a simplified model of how you think other people behave, where you say, well, their actions and the reactions you see are kind of caused by mental states, right? Like you think that there's such things as like beliefs and desires inside people's minds. And from this standpoint, people usually talk about social cognition as kind of mental state attribution. So they say, well, what it means to be doing social cognition is something like trying to attribute mental states, right? It's saying, you see someone move around and I'm trying to figure out what are the beliefs and what are the desires in your mind. And it is like, if I can get those, then I get a lot of social power, right? Because if I get those, I can kind of understand intuitively what you're doing. I can use to make predictions. I can figure out how to interact with you. So getting access to those mental states is really important. And of course, it's a very popular idea. I think it's shaped a lot of social cognition, right? A lot of the literature on developmental science focus on figuring out when can children represent these kinds of mental states and infer them. It's a very big question in comparative cognition, like to what extent do non-human primates share these representations when they're reasoned socially? It's a big idea in language that the way we can reason about non-literal meaning is just kind of like recursive mental state attribution. And it's a big target of kind of computational modeling. In computational modeling, we often think that getting human-level social intelligence means being able to get something that you see someone moving around, and then you figure out what are the beliefs and desires that explain the behavior. But the claim I want to make today is, first of all, I just want to point out, like, of course, representations of other people's mental states matter. But I've become increasingly convinced that this isn't everything, and it's actually missing a really big part of what social cognition is. To show you what I mean, I'm just going to play this video again. I slowed it down, and I'm just going to walk you through. Maybe I can try to point with, yeah. Try, and I'm just going to point to like some inference that come to my mind when I'm watching this, right? So here, you can see there's a cop that's kind of walking around and turns around, kind of sees something, and then goes back the other way. And here's a man in pink that's kind of walking. Then he looks to his left to the train table, and then keeps on going. And here you can see a man that's just kind of like standing there doing nothing, just staring at the screen, maybe waiting for the information to show up. Here you can see two people that are kind of like walking and talking, and you can see they're not really tracking you. They're not probably aware of you. Here's another person. You can see that she seems just kind of tired, kind of had a long day, and just kind of like lost in thought. Here's someone that's in a hurry. They're just kind of like running around very efficiently. here's another person in a hurry, but his movement was a little bit clumsier, right? He just kind of keep like almost bumping into people and then correcting it. And the main thing I want to point out is when I was giving you this narration, I don't know how, hopefully it was smooth enough that you could see what was going on. I wasn't actually walking around telling you, this is what this person believes and wants, and this is what this person believes and wants, and this is what this person believes and wants. In fact, most of the time I was actually using mental state placeholders. I was like, oh, this cop saw something and they're going somewhere and this person is going somewhere. So most of them actually didn't really know what was the exact kind of the beliefs and desires. So it's just like, they know something, they notice something, and they're going somewhere. I think what we're really doing was something more like tracking real-time mental processes. And what I mean by that is like, we were trying to watch and say like, where is this person's kind of like mental life right now? Like, are they aware of their surroundings? It's kind of like moving inwards. Are they paying attention to this? Are they basically kind of like, it's like what's going on in their minds? And I think this is the key to explaining how social cognition gets us to the kind of like the really, really complex social behavior that we ultimately want to explain, like complex cooperation or social planning or language, or maybe some aspects of social curiosity. So the idea here is, again, I want to emphasize, I think this matters, but I think it's not like that when we get beliefs and desires, when we infer them, we're done with doing social cognition. I think that's actually the background. And then the real social models that we use are kind of like these arrows, right? So you get those, and then what you're really trying to track is kind of like, what is the dynamic nature of a mind? And if you think about it, like we actually often define the theory of mind that way, right? Like say it's thinking about thinking. So I really think like we need to put like the active part in it. So what I'm going to do today is I'm going to just walk you through kind of in part how I got to becoming more convinced about this idea. So I'm going to show you kind of, it's 2 case studies and then some more direct approach of trying to like figure out what this would look like. So I'm going to talk a little bit about language, then gesture, and then action understanding. And then at the end, I'm going to say a little bit about how I think this can be relevant to thinking about social curiosity. Okay, so the way we started working on this was when so for those of you who don't know me, I've usually been a very big promoter of mental state inference. Like I've spent a lot of my time saying mental state inference is the thing. This is what really matters. And when I started working on this, we were kind of interested in figuring out like, how can you build a computational model that can infer mental states? But when you have that, you can also ask another question that I found very interesting, which is at what level of resolution does social cognition have? And what I mean by that is you can kind of think of representations as falling kind of in a spectrum where you can think of like there's qualitative to quantitative to qualitative. So quantitative are usually representations that we associate kind of like with perception and low level cognition, right? So kind of like object tracking or motor control, right? So if you think of like right now, what are the representations I need to have to be able to do this and just pick up an object? It's not just enough that I know that there's a magazine roughly somewhere around here. I need to have like a very sharp representation of where exactly it is so I can do like kind of a quick movement, right? Or envision like as you're moving around quickly, you need to have like very quantitative representations of your space. And that's what allows us to kind of like move in this very kind of like powerful way. And then on the other end, you have kind of like qualitative inferences that are kind of like usually associated with high level cognition. These are the things that just like, oh, we can kind of do this, but it's a little bit of a blurrier inference. Right? This is kind of like often what we see in judgment under uncertainty, where we say, well, people can sort of get the answers, but they're not quite rational. They get them a little bit wrong, or it's a little bit fuzzy. And so we were wondering, okay, where do mental state inferences fall? Right? And I think often when people think about mental state inference, we think of like these really complicated cases, like when you're understanding sarcasm or things like that. So we tend to think that like theory of mind is a little bit blurry and like we can sort of figure out, but not quite. And something I thought was just kind of amazing is it turns out that if you go to kind of like the most basic forms of social cognition that you have to do so when you see just an agent moving around and you have to figure out what does this agent know and what do they want, the representations seem to fall a lot more on the quantitative end. This doesn't necessarily mean knowing always what's exactly in other people's minds, like sometimes you just can't, but it means that when you don't know, you have a very accurate representation of the uncertainty. So the idea is, right, so just to recap, like you have an agent, and if you're watching someone else, you say, okay, they're moving around. How can I extract the beliefs and desires from this agent? And it turns out that we can make these kind of like very, I'm going to call them high resolution inferences. And we thought, well, maybe this makes sense, but maybe this is just specialized for processing physical action, right? Because if you think about it, like the problem of being able to process physical action is a problem that's not unique to humans, right? A lot of creatures need to be able to like quickly process other action. And there even seems to be the case that like that even when you go all the way down to vision, we heard this a lot yesterday from Lou, but like there seem to be specialized pathways for social computation, to the point there's a proposal that there's actually a third pathway that's functionally and anatomically distinct from the ventral and dorsal pathways that's really special for social computation. So like, okay, maybe this is not reflecting that theory of mind is that powerful. It's just reflecting that like processing body movements is just like this such an important thing that we're really good at that. So we were like, let's see what happens when you replace the data with linguistic interactions, right? So it is like saying, this is a totally different kind of data set, right? It's coming from a different stream. You're hearing it instead of seeing it. But it's also a case that it's what people say is a window into their minds. And it turns out that people are also really, really good at this. At least when you're gonna go these very simple linguistic events, people are very good at extracting these things. And you might notice that like sometimes when you're talking to someone, like they can use like a certain choice of word immediately trigger something. You're like, wait, how did you know that? Or you realize like, oh, maybe they don't know what they're talking about. And it's the kind of stuff. I mean, so when we're at this point, we were like, okay, so there seems to be no differences in mental state inferences when you're passing basic physical action or verbal utterances. And we're like, that's kind of cool because that means like the system is abstract enough that it can handle physical action or sounds. And if you think about it, you might say, well, actually, that's not that surprising because the two fields that have worked on this in parallel kind of have made the same point. In physical action, they tell you, well, we infer that the basic inferential agent is that agents move as efficiently as possible, right? That's why if you see that little ball jump over behind an occluder, you infer that there's an object behind there. You're like, why would this agent be moving that way unless there's an object there? And then if you look at speech, people will say, speak as efficiently as possible. That's a principle, right? And that's why if someone says something like, can you pass me the big blue bowl? You say, well, it must be the case that there's a lot of bowls that are kind of different sizes and different colors, because otherwise, why wouldn't you just say, pass me the bowl, right? So from this standpoint, you can be like, okay, yeah, this makes sense. It's the same principle that's operating. But there's one problem, which is if you show this kind of like, I think it's just my favorite experiment, you just show people this and you ask them, what would you call this? And hopefully many of you have the intuition to say, well, that's a red cup. And if you think about it, that's actually a problem because you just used an unnecessary word. Like you were just supposed to say cup. There's just one cup. So on the one hand, I just told you that as listeners, we're inferring very nuanced mental states by picking up very subtle speech inefficiencies. We're very sensitive, like a word choosing. We're like, oh, that reveals something. But on the other hand, there's this data that says that people just introduce these meaningless inefficiencies in speech all the time. We just use words for no reason. So if these two things are the case, then we have this kind of sophisticated theory of mind that's just totally failing us because people are using words just for their sake, and we're like really trying to extract what's going on. So, and the puzzle with this, what we think is missing is that this is not what the world looks like, right? The world is not a blank screen with a floating cup. The world looks more like this. And if you were here, you might think, okay, suppose there's actually only one cup here. What would you prefer I tell you? Pass me the cup or pass me the red cup, which is right there. Right, so if you think about it, even though there's only one cup, and technically saying red cup is being inefficient, it actually is more useful. Wait, is there more than one cup? Oh my God. Actually, I forgot this. That is a true cup. And I was just like, oh, it's too hard to find. I need to move it. And then I forgot to do the first one. Right, good. At least I know you're all paying attention. But so we're like, okay, so maybe what's happening is that this is a form of kind of like pretty sophisticated social cognition. Maybe as speakers, we're not just saying, are you going to be able to infer like my mental state, assuming there's just one cup? We're saying, what is going to be the actual mental process for you that as I'm speaking, you're going to be looking around and you're going to try to like figure out what's there. So I'm just saying red cup because I think like using red is just going to be helpful to you. And that makes kind of two predictions. The first one is that people should use more color words and more complex visual environments, right? If there's just one object, the color word is not going to be that useful, but if there's a lot of objects, then using the color word is kind of useful. It's just going to really help the listener. The second prediction is that if you speak a language like English or German, I believe, you're going to use more color words than if you speak a language like Spanish. And the reason for that is because if you're an English speaker, you say red cup. But if you're a Spanish speaker, you would say vaso rojo, which represents the cup red. So in Spanish, you put the adjectives after the nouns. And that means that if you're really doing the sophisticated thing, by the time I say, if I'm speaking Spanish, if I want to give you the color word, I have to wait until I've given you the noun. And in that time, you're already looking around. So it might be that in that time, you can kind of decrease saying like, well, now there's a chance that you already found the object. So maybe the color word is not going to be that useful. So here's the data. Here's a very simple experiment. There's just 4 objects. There's 1 triangle. And we just ask, what would you call this? So all you need to say is just triangle. But English speakers, about a third of English speakers would say that's a blue triangle. But if you test Spanish speakers, no Spanish speaker basically virtually says blue triangle. Every Spanish speaker says that's a triangle. But now if you go to 16 objects, again, there's only 1 triangle. So you're only supposed to say triangle. Now you get no difference. Around like 80% of both English and Spanish speakers start to call that a blue triangle. So at this point, we're like, okay, this is cool. But it's also just kind of like, it's a very subtle difference, right? People on average use, I think it's like about 150 words per second. So 1 word is 400 milliseconds. So I'd be like, do 400 milliseconds actually matter? So what we did is we did this task where we kind of did like 2 equivalent versions of the task. One version I'm going to call the speaker task, where we just show a bunch of objects and we're like, hey, would you call this a metal chair? And you just give a rating from 0 to 100, right? We're not talking, that's just literally that question. We just like, would you call this a metal chair? Nothing about visual search. So for each object with the distractors, we have a rating of how much people like calling the object. And then we take the same scene and we do a listener task where we just tell people, click on the metal chair. And we record how quickly they find it. And this one, we didn't actually record we do eye tracking. This is just to kind of like highlight the idea of like, when people hear click on the metal chair, they quickly like try to look around and find it. So for each object and scene, we have 2 data points. We have how much people say that sounds, I would call that whatever description, and then how quickly someone can click on the object when you give them an utterance. And this is what the data looks like. So each point here is an utterance. So on the x-axis, you have how much people say, yeah, I would call it that. And on the y-axis, it shows how quickly people can click on the object when they hear that expression. So you get a very nice negative correlation that trusting to suggest that speakers prefer utterances that are supporting this kind of like the listener's real-time visual search. And it's actually like pretty nuanced. Did my talk start at 11:30? Okay, so I need to go until like, so do I have like 10 minutes? Okay. I did some random deleting of slides and I have no idea how long this is, but I can jump around a little bit. So then we're like, okay, this is nice, but let's try to actually build a model. Charlie did an amazing job yesterday explaining models. And I was like, I can't do that. So I'm going to do the opposite. I'm not going to explain the model at all. But I'm around, so I'm happy to talk about it in detail. So I just don't want to, I'm as good. But the basic idea of saying like, okay, let's build a mental state attribution model. So these are kind of like the standard models that we've all been building. We say, well, if I'm figuring out how to talk, I do need to figure out like, is my speech gonna get the right mental states in your mind, right? So it's kind of like, what is the most efficient way for me to get you to know my mental states? So in this case, it might be like, how do I get you to know what I'm talking about? So this is the kind of model that will say, call it a cup, because if I say cup, it's an efficient way for me to speak, and there's only 1 cup. And we contrast that with a model that's kind of like tracking more of a real-time model of how a mind is dynamic. So the way this one evaluates the utterance is by saying, as I speak, it's not just kind of like this, is there enough information in the utterance? I'm going to have a process where I'm considering like, as I'm speaking, you're hearing what I'm saying and you're looking around and you have different kind of like visual abilities, right? If I use something like a material word, that might be a little bit hard for you to find, but color is easy for you to find. And it's this idea of saying like, well, how can we get my listener to kind of like efficiently process what I'm saying? Like, so how can I be really helpful to you when I'm speaking? So I'm just going to show you some quick simulations to give you the idea. So here's the simulation where we say, okay, let's just give it a scene and let's just start adding more and more objects, where the object that you're talking about is always unique. So you never need to use any redundant color words. And our model likes to, like humans, it starts like adding more color words as you increase the number of objects. Then you can say, okay, what if we leave the number of objects constant? In this case, it's 9. And we start with making every object a different color. And then we slowly start making everything the same color. So it's actually a known effect. So it turns out that if you're in a natural scene, people say red cup. But if you're in a room where everything is red, no one says red cup. Everyone just says cup. And we kind of like a similar pattern. So as you start making the scene monochrome, the model starts saying like, yeah, I don't want to use a color word. And then we can also manipulate where it gets to put its adjectives. So we can tell you like, you can speak an English, a language kind of like English, where you put adjectives before nouns or after. And we also can replicate that effect, right? So we can get the effect where in both languages, the more objects, you like using more color words. But if you're speaking a language like Spanish, it likes it a little bit less. So okay, that looks cool to us at least. And since these were known effects, we were like, let's just go and take the data from these 4 papers and look how it correlates with the model. So here, each point is a data set from an experiment that was run before we had any of this. So on the x-axis is our model, and on the y-axis is actually proportion of people that actually like to overspecify. That's just gonna skip, but we also have like a more detailed experiment where you can actually contrast that, like mental state attribution works, but it actually gets a lot of stuff wrong. But okay, so that's one case in language where hopefully I've convinced you, like, it seems to be like a little bit of kind of like very nuanced real-time processing. But then again, you might say, well, language, I mean, we know that language is very unique. Language is its own kind of category of like very complex system. So here's a second route where we started thinking about this is kind of a totally independent project in gesture, where my graduate student, Amanda, was kind of interested in asking, what are the forces that shape how we produce and understand communicative action? So Amanda's point was, okay, we claim that we have like a fairly good understanding of how you infer beliefs and desires when people are kind of moving towards goals, right? Like all of the studies are like you're moving towards objects and you're grabbing them or like trying to collect things. But a lot of the actions that we move are actually not trying to change the world, right? They're communicative, like when you're waving or nodding or winking, those are all for a different purpose. And for those of you who know a little bit more about the gesture world, you know that gesture is actually like, it divides into like a whole taxonomy. So for those of you here, I'm talking specifically about emblems, which is a subcategory of gesture. If you don't care about it, you can just ignore this part. So we thought, okay, from a mental state attribution perspective, he's saying like, all I need to do when I'm communicating, I need to get the right mental state in your mind. I need you to get to believe that the movement is communicative. All that matters is that I produce a movement where like you ultimately know what I'm doing. But if you have a kind of a more nuanced model where you're tracking like what is a real-time process, you can also consider how easy is it going to be for the observer to try to recognize this, what I'm doing. So we came up with this hypothesis that's saying, well, maybe this kind of communicative action is shaped to try to efficiently guide your mind towards realizing that I'm communicating. So it's kind of like guiding the fact that like you're thinking in real time and I'm trying to get you to move in that direction. So we can actually take this computational and figure out what would that look like. So just to contrast, I will show you like what it would not look like. This would be a bad solution according to our theory. So here, imagine that there's a bunch of objects and that little white circle is an agent. And if this agent were trying to communicate in 2D space, this would be an example of a bad solution. Because if you move here, by the end you've seen it, you're like, okay, I guess you weren't collecting stars, so you might be communicating. But if you imagine the unfolding process, you might be like, oh, maybe you're going for this one. No, I guess maybe you're going for this one. Oh, you changed your mind. And then it just takes you a long time to get to the inference. But according to our account, there's kind of some good solutions, which kind of, they're actually a single category, but you can think of them as 2 categories. One of them I'm going to call rarity. And the idea is basically that if you're in a world like this, produce a movement that you would, it's very unlikely to be produced under the statistics of when you act in your environment. So it's kind of like you're saying like, move in this direction, because as soon as you move away from the object, you're kind of like canceling out the possible interpretations of instrumental action, right? So we don't know if that's the case, but intuitively, it's something like when you're doing like a thumbs up, you're moving your hand in a direction that's like very rare that you would be moving. So it kind of like helps quickly guide them. The other solution is repetition. So if you imagine you're in a world like this, so like any way you move, it might kind of look like you're acting on the world. Turns out like you can very efficiently guide the inference of your observer by just repeating the movement a few times without changing anything in the environment. It's kind of like in one direction, you could be doing one thing, and the other direction, you could be doing another thing. But if you do them both, then it just becomes inconsistent with anything. And we're kind of like, that feels kind of consistent with the fact that when you wave, it feels a little bit weird to wave once. It's just like you want to do it a few times. So when we nod, like we like doing a little bit of repetition. So we're like, well, let's see if this is true. So we, and by we, I mean Amanda, collected over 300 gestures from over 34 countries. And we just basically had a lot of coders go through them and figure out what is the distribution. So here's what it looks like. Each square here is a gesture. And what we found is that very clearly coded, almost 96% of the gestures seem to be shaped to kind of like they follow these features of rarity and or repetition. And we only found that 4.18% were inconsistent. And I can talk about it. These edge cases that we did not predict are kind of interesting. So it looks like these gestures are shaped in this kind of way, but you might say, you're like, okay, maybe they just got shaped by some kind of cultural evolution. I'm not going to talk about it, but we did like synthetic experiments where we tell people you have to invent a new gesture, and it turns out that immediately people will do it, and we manipulate the distribution of goals. So it happens within as early as like in a single round, and in one-shot interactions, people know how to do this. And then I was asking, well, but is this actually how people recognize communicative action? Because you might say, well, as observers, you don't need to do any fancy inference. Like we already know what gesture looks like. Like we know this is a wave. So you just have kind of like a dictionary in your mind of like, these are the movements that are communicative, and you just recognize it. So we came up with a bunch of movements. These are made by design, but then they're also normed. So like you have basic movements that are kind of like something that might look like you're doing some goal-directed action. Then we add some rarity, like you separate it spatially, so like kind of a weird movement, or you can add repetition, or you can add both. And basically, we tested this in a bunch of ways. We asked people directly, how communicative do you think each of these movements are? We also did open-ended explanation. We showed the movement, and we're like, what do you think is happening? And I think Amanda ran a total of 13 experiments when you include controls. The basic, it works. But I'll just show you my favorite experiment from that, which was an indirect measure where we did a version where we don't tell people that this is any kind of communicative task. And we just show the video and we tell people, you have to infer if the person was alone or if there was someone else in the room. And if you show one of the basic movements, most people will say, I guess the person was alone. But if you show a rare and repetitive movement, everyone says there was someone else in the room. And we also replicated a bunch of the experiments with the Chimani, who are a farming foraging community in the Amazon, because we're also worried that maybe this is kind of like an extrapolation from like the kind of like gestures that are very like Western that like US participants would be picking up on, but it seems like that's not the case. Okay, so that's the second case. So sorry, I get excited and then I talk too fast and I can't tell until like I stop and I'm just like, I'm out of breath. So, but yeah, hopefully it wasn't too fast. And I'm sorry, I forgot. I have 15 minutes left. 5 minutes left. Okay. Gotcha. Well, I want to spend some time. I'll just very quickly say we've been building some models because again, it doesn't matter too much, but the basic idea here in the model is saying like, let's try to actually get these models and figure out like, what are the inferences that we make about mental processes? And kind of like a motivating example is if you imagine that, suppose you're playing chess with someone and you make a move, and as soon as you make the move, you're like, oops, I just lost my queen. Like now it turns out the other person can take my queen immediately in one move. But I suppose that the other person just like sits there and stares at the board. At that point, like if you're playing against novice, you might be like, ooh, maybe they haven't realized. Or if they keep waiting longer, you might be like, maybe they did realize, but they think I'm doing something clever and they're trying to figure out like, why would I make this? Am I doing something kind of smart? Or if you're playing against a grandmaster, Magnus Carlsen, you might be like, oh, this person just is totally uninterested. They're just like thinking about what they're gonna eat afterwards, and they're clearly like not even paying attention to the board. For this, if you have followed Chess World, I don't know how many of you have been following the recent drama. Can I get just like a show of hands? Okay, not everyone. So Magnus is one of the best players, and he recently played against another chess player that has been climbing up the ranks very quickly, and Magnus lost. And he basically came out saying like, this person must have been cheating. And if you look at the statement, it says, I could tell that like there were key moments in the game where the other person didn't seem engaged in the board as like I would expect. And they didn't seem stressed and they just seem kind of distracted. So it's kind of like a mental state of basically saying like, there's these cases where I felt like the amount of cognition that you should be putting into the task just didn't match the cognition that you were putting in. And there's other cases, like you said, of cheating in this case. So yeah, if you just Google, I don't know, I feel like if you just Google chess, it's just gonna come up because it's everywhere right now. So those are the kind of models that we've been building, where you watch an agent and as they're doing their goals, you can kind of track how much computation would an agent need to do in their environment. And based on that, we're finding that you can make kind of like a lot of kind of neat inferences. Like if someone pauses, I'll just show you like a few. That was actually, here's one where like there's an agent navigating a maze, and you can see that if the agent pauses at some points, those pauses feel like, oh, the agent stopped to think about what to do. But we can manipulate the pause, and if the agent pauses for a little bit too long, people start to say like, oh, maybe the person just got distracted. This video is way too long, but we can also do these. We've also done this with like kind of these puzzles where you see someone just kind of like thinking about the puzzle and eventually they're like, oh, I got it. And they do the solution. And then you have to infer, how long do you think they ever got distracted? Or how fast are they thinking? Or like, do you think they already knew the answer? And you can get all these inferences. If you're tracking amount of computations, you can basically say, here's how much thinking I think is required here. And if you're a little bit shorter, you're like, oh, you're a fast thinker. But if it's too short, you can say, there's no way any mind can do computation that quickly. So you must have already known the answer. Or if it's short and it's just the pause goes for too long, you can be like, you must have been getting distracted because it can't be possible to do that. Okay, so very last minutes. I'll just quickly tell you how I think this could be relevant to social curiosity, but maybe it's not, and you can all tell me why I'm wrong. But when I got invited to this, I was starting to think of like, okay, in what ways am I socially curious? And I came up with this, I don't know, this is what I've been thinking, which is, I don't know exactly how to talk about this, but I would say like other people's minds, you can think of as having kind of like surface structure. And what I mean by that, they're kind of like the desires and goals that people are actively trying to fulfill, or the beliefs and knowledge that are relevant to the situation, right? So as I'm moving around, there's some very immediate mental states that I have mental processes that I'm acting on right now. Those are like very reflected in my behavior. Right, so that surface structure kind of like shapes my behavior in a very observable way. And that's something like we're very good at extracting. And that's often like what we study experimentally. Like all of these studies are saying like you see someone move around and you're trying to extract kind of like what are the active mental states that you're on. And I say these representations of the surface structure really matter for like what I'm going to call right now like reactive social cognition. The idea like if I see you and I'm like, oh, you're trying to complete this, let me help you. Or I'm trying to kind of like, I'm just seeing like what mental states are you acting on? And then I figure like, how do I interact with you? And I think we do experience curiosity when we can't infer that, right? If you see an agent, you're like, where are you going? That's the kind of curiosity that we experience, right? So I'm going to call it, you can think of these are like, what are you doing moments of like, when you see someone, you're like, what is going on? This is terrible terminology, but I'm going to say, but there's a deeper level that I'm kind of calling it like dark matter in people's minds. And what I mean by that is it's kind of like this deeper mental life that we know everyone has. It's kind of like their ambitions and dreams that people like don't act on, like the I want to quit this and go and open a bakery, or the conversations that people have with themselves in their minds, or like everyday mind wandering. And I think these kinds of like this deep mental life that in some sense like what it really means to kind of like be a human, it's kind of like not very observable to us. I think it does shape behavior, but it shapes like kind of like this very subtle way that our theory mind is just unable to extract. Right? From seeing me move around, you can feel like, what is my goal? But you can't figure out like, what are like these deep thoughts that I have that I'm kind of like ongoing in my mind. And I think this is the mental life that we're often most curious about. Like I found myself in these days, like if I'm, like driving with my partner and like they're wandering off, I'm just like, what are you thinking about? And there's things like, what are you thinking about? Like sometimes like you're like, oh, I wonder what they were thinking. Or like you see someone, you're like, I wonder what this person would think about this. So I think there are often like these inferences about the mental processes. And one question is, well, but why would we be curious about it? So I'm saying like, it doesn't seem to influence behavior that much. Like, why should I care what's going on? It's kind of like background chatter that is not relevant to social cognition. The reason I think it is because I think if you know the surface level, it's what I mentioned, like you can kind of do this kind of reactive in the moment social cognition. But if you can get access to like this deeper kind of mental life that people have that you can't infer from behavior, I think that is what really enables you to kind of like create radically new kinds of social relations and new kinds of goals, right? It's not the kind of like you see someone completing a goal and you're like, let me help you. It's knowing what is that mental life that they're not acting under. And if you have access to that, then you're able to kind of say, let's do these new things together. So I think that's kind of like a very unique way in which we can kind of create new things with other agents if we know kind of like that deep stuff. And with that, I'll end. And yeah, I mentioned most of all of the work that I presented was done by Paula, Amanda, and Marlene, but it was, of course, shaped by everyone that's in my lab and that's just contributed like in different ways to this conversation. Thank you.